Hello everyone, welcome first year students English section, Faculty of Commerce, Sadat City University. This is Reem Sobhi. I'm a teaching assistant at Insurance Statistics and Mathematics Department. This is section 8 in Pure Mathematics course on chapter 3 titled Quadratic Equations. Again, our learning objectives from this chapter is to know what do we mean by quadratic equations and to know some different methods of solving quadratic equations. In section 7, we already take factoring method and square root method. In this section, we will use completing square method and quadratic formula method in order to solve quadratic equations. Let's start with completing the square method. Sometimes the equation cannot be solved directly by factoring or by the square root methods, such as x squared minus 10x minus 3. This equation or this quadratic equation cannot be solved using factoring or square root method. So we can use more general method by transforming the equation of the form ax squared plus bx plus c equals 0 into the form of x squared plus bx equals to c. And this by following these steps as follows. The first step is to divide the equation by a, and then a by a equals to 1 and b by a and c over a. Let's say that a equals to 1. Then the equation will equals to x squared plus bx plus c equals to 0. The second, and this x squared plus bx plus c equals to 0. Put the term that's independent of x in the right-hand side, and the term which is independent of x is c, so we will put this term in the left-hand side, in the right-hand side. Step number 3 is to divide b by 2 and square the results. Then add this square to both sides, to the left-hand side and the right-hand side. As you can see here, we divide b over 2 and square the results. Then we added this term to, or this square, to the right-hand side and the left-hand side. Write the left-hand side in the form a plus x plus a to power 2, then x plus b over 2 all power 2 equals to c plus b over 2 all power 2. After that, solve the equation by the square root method. Let's take some examples in order to clarify the idea. Completing square method. Use this method to solve the following examples. Using completing square method, the solution set for the following equation is, and the equation is x squared plus 2x equals to 3. By looking at this equation, we can see that the equation is already in the form of the completing square, and the constant term in the equation is on the right hand side, which is 3. The second step is to divide b by 2, and b here is 2. So x squared plus 2x plus 2 over 2 squared equals to 3 plus 2 over 2 squared. As we should add a term, but which is b over 2 all square. And we should add this term at the left-hand side and the right-hand side. And b here equals to 2, so 2 over 2 square equals to 3 plus 2 over 2 square. And this equals to x squared plus 2x plus 1 square equals to 3 plus 1 or 4. And by putting x and 1 square into one bracket in this form, x plus 1 all power 2 equals to 4. After that, we can solve this equation by taking the square root, and square root of both sides gives us x plus 1 equals to plus or minus 2. Then the solution set is x equals to minus 1 plus or minus 2. And we can say that is minus 1 plus 2 equals to 1, and x equals to minus 1 minus 2 equals to minus 3. So the solution set is minus 3 and 1. And the correct answer is A. Another example, by using the completing square method, the solution set for the following equation is, again, we should put this equation into the form of the completing square, and this would be y squared minus 4y equals to minus 3. We should put the constant term in the right hand side of the equation. After that, adding a term or a coefficient in both sides, and this coefficient equals to b over 2, and b here in this equation equals to minus 4. So y squared minus 4y plus b over 2 or minus 4 over 2 square equals to minus 3 plus, again, the same coefficient, minus 4 over 2 square. And this would equals to y squared minus 4y plus minus 4 over 2 equals minus 2 square, and minus 3 minus 4 over 2 gives minus 2, minus 2 square gives 4. So y, we can say in this stage that y minus 2, we put y square and minus 2 square in the same bracket. So y minus 2 square equals to minus 3, and plus 1 equals to 1. By taking the square root for both sides, we get y minus 2 equals to plus or minus 1. And this means that the solution set equals to y equals to 2 plus or minus 1, and this means that the solution set is 2 plus 1 equals to 3, and 2 minus 1 is 1. So the solution set is 1 and 3, and the correct answer is D. Another example, using completing square method, find the solution set for the following equation, which is 2x squared minus 7x plus 3. First, we have to simplify this equation by dividing all terms by 2. And this would equals to x squared minus 7 over 2x plus 3 over 2 equals to 0. After that, we have to put the constant term in the equation at the right hand side, and this would equals to x squared minus 7 over 2x equals to minus 3 over 2. The second step is to add the coefficient, which equals to b, and b in this equation equals to minus 7 over 2, and the coefficient would equals to b over 2 square. So x squared minus 7 over 2x plus b over 2, and b equals to 7 over 2 times half all square equals to minus 3 over 2 plus minus 7 over 2 times half all square. And this equals to minus 3 over 2 plus 49 over 16. Again, x squared minus 7 over 2x plus minus 7 over 4 square equals to sorry, 25 over 16, or 5 by 4. 25 over 16. Putting x with minus 7 over 4 all square equals to 25 over 16. By taking the square root for both sides, we get x minus 7 over 4 equals to 5 over 4, or plus or minus. And this would equals to x 7 over 4 plus or minus 5 over 4. So the solution set is 7 plus 5, 12 over 4 equals to 3, and 7 minus 5 equals 2 over 4, which equals to half. So the solution set is half and 3, and this equals to D. So the correct answer is D. Another example, using completing square method, the solution set for the following equation is: the first step is to divide all terms by half, or multiply with 2 in order to rid of these 2 in the denominator. So 2 times x squared and 2 times 2x and 2 times quarter gives us x squared minus 4x equals to half. And in this equation, b equals to minus 4. So the next step is to add the coefficient, which is b over 2 all square. So x squared minus 4x plus minus 4 over 2 all square equals half plus minus 4 over 2 all square, which equals to minus 4 over 2 gives us minus 2. Minus 2 square is 4. So half plus 4 equals to 9 over 2. So x squared, or x minus 2 all square equals to 9 over 2. By taking the square root for both sides, we can get x minus 2 equals to 3 over square root of 2, plus or minus. So the solution set for x is 2 plus 3 over square root of 2 and 2 minus 3 over square root of 2. And the correct answer is A. Another example, using completing square method, the solution set for the following equation: t squared over 3 minus 2t over 3 plus 5 over 6 equals to 0. First we should rid of the 3 at the denominator, and this by multiplying all terms by 3. So 3, 3, 3. So 3 goes with 3, and 3 goes with 3, and 3 goes with 6 gives 2. So t squared minus 2t plus 5 over 2 equals 0. The second step is to put the constant term on the right hand side. Then t squared minus 2t equals minus 5 over 2. The second step is to put the coefficient, which is b over 2, and b here equals to minus 2. So t squared minus 2t plus minus 2 over 2 whole square equals to minus 5 over 2 plus minus 2 over 2 all square, which is minus 1. Minus 1 square equals to 1. And this equals to minus 5 over 2 plus 1. So by normalizing the denominator, this would equals to minus 3 over 2. And t minus 1 all square equals to minus 3 over 2. By taking the square root of both sides, we get t minus 1 equals 2. And by uh, looking here at this square root, we can see that there is a negative sign under the root, and there is no square root for any negative numbers. So we will use the imaginary numbers, then I plus or minus I square root of 3 over 2. And the solution set t equals to 1 plus or minus I times square root 3 over 2. And the solution set is 1 plus I square root of 3 over 2 and 1 minus I square root of 3 over 2. And the correct answer is A. But there is no negative sign here. There is a mistake in the solution. The fourth and last method is the quadratic formula method. If we solve a general quadratic equation, ax squared plus bx plus c equals 0, where a doesn't equal to 0, by completing the square and using the square root property, the result is a formula that gives solutions for x in terms of a, b, and c. This formula is x equals to minus b plus or minus square root of b squared minus 4ac over 2a. And this is the general quadratic formula. Note that the term inside the radical, which is under the root here, that is b squared minus 4ac, and this term is called discriminant, gives important information about the solution set of the equation, as it takes three cases. If the discriminant under the radical is positive, then we have two distinct real solutions. If the discriminant is 0, then we will have only one real solution. If the discriminant is negative, then we would have two complex solutions or no real solutions. By using quadratic formula method, find the solution set for the following equation. First, we have to find a and b and c. So a equals to 1 and b equals to 3, where c equals to minus 1. By substituting the value with the values of a, b, and c in the general formula, which is x equals to minus b plus or minus square root of b squared minus 4ac over 2a. This equals to minus 3 plus or minus square root of 3 squared minus 4 times 1 times minus 1 over 2 times 1. And this equals to minus 3 plus or minus square root of 15 over 2. And the solution set would equal to minus 3 plus square root of 15 over 2 and minus 3 minus square root of 15 over 2. And the correct answer is A. And as you see here, the discriminant or the value under the root or the radical equals to 13, which is positive, and this means that we will have two distinct real solutions, and this is true. Again, another example, by using the quadratic formula method, find the solution set for this equation. First, A equals to 3 and B equals to minus 3, where C equals to minus 4. Again, by substituting with the values of A, B, and C in the general formula, we can get the solution set of X, which is minus B, so minus 3, plus or minus square root of B squared, so minus 3 squared, minus 4 times A times C over 2A. And this would equal to 3 plus or minus square root of 9 plus 84 over 6. And this equals to 3 plus or minus 75 over 6. So the solution set would be 3 plus square root of 57 over 6 and 3 minus square root of 57 over 6. And the correct answer is F. Another example, using quadratic formula method, find the solution set of this equation. 3x squared plus 5x equals minus 11. Again, we should first put this equation into the standard form, which is 3x squared plus 5x plus 11 equals to 0. And A equals to 3, where B equals to 5 and C equals to 11. By substituting with the values of A, B, and C in the general formula, we can get the solution set of X, which is minus B, so negative 5, plus or minus square root of B squared minus 4 times A times C over 2A. And this equals to minus 5 plus or minus square root of 107 over 6 as 25 and minus 107 negative 5 as there is 33 times 4 gives us 32, so 25 and 25 from 132 gives negative 107. So the solution set is minus 5 plus, and we don't have a square root for a negative number, so this equals to I times 107 over 6, and also negative 5 minus I times square root of 107 over 6. As in this solution, we get a negative discriminant under the radical, and this means we would have another questions determine whether the following statements true or false. The number that should be added to complete the square of the following expression is, this is the expression, x squared plus 6x, and we should add a number to complete the square, and this number equals to b over 2 all square, and b here equals to 6. So the number is b over 2 all square, and b in this example or in this expression equals to 6. So the number that should be added equals to 6 over 2 all square, and 6 over 2 gives 3 square. So 3 square is correct. The number that should be added to complete the square of the following expression is, again, the number equals to b over 2 square, and b here equals to negative third. So the number that would complete the square equals to negative third times half, which means over 2 square, equals to minus 1 over 6 square. So again, this is correct. Number 3, the number that should be added to complete the square of the following expression, again, b over 2 whole square, and b equals to negative 8. So negative 8 over 2 whole square equals to negative 4 square. So this is correct. The number that should be added to complete the square of the following expression, again, b over 2 square. This is the number that should be added to this expression to complete the square. And b here equals to 4 over 5. So 4 over 5 over 2 or times half square equals to 4 over 4 square, and this means 1 square, and this is false. Sorry, 4 over 5 times half, this means 4 over 10. 4 over 10 and by 2 equals 2 over 5, and this is not a 5 square. So again, the statement is false. Question 5, the discriminant inside the radical b squared minus 4ac for this expression is positive, and the solution has two distinct real solutions. We don't know. We should first find the value of the discriminant, and a equals to 1, where b equals to negative 22 and c equals to 121. By substituting with these values in the discriminant, then b squared equals to negative 22 squared minus 4 times a, which is 1, times b, which is 121, and this equals to 484 minus 484, and this equals to 0. So the discriminant equals to 0, and this means that we only have one solution for this expression. So the statement is false. The second statement, um, the discriminant inside the radical for this expression, 9x squared minus 7x plus 8 equals 0, is 0, and the solution is one real solution. Let's again find the value of a, which is 9, and the value of b, which is minus 7, and the value of c equals to 8. After that, we should substitute with these values in the discriminant value, and this equals to minus 7 squared minus 4a uh, times c, which is 8, and this equals to 49 minus 288, and the answer is 239 minus, and the answer of this question is false, as the discriminant is negative value and we only have two complex solutions. Question 7, the discriminant inside the radical for this expression is negative and the solution has two complex solutions. First, we should find the value of A, which equals to 2, and B equals to minus 30, and C equals to 68. Then, by substituting with the value uh, of A, B, and C in the discriminant, we find that minus 30 squared minus 4 times A times C equals to minus 8 times 680 equals 544, and the answer equals to 356. So the answer is false, as the discriminant is positive, and we would have two real solutions. Question A, the discriminant inside the radical for this expression, minus 3y squared um, plus 27y plus 66 equals to 0 is positive, and the solution um, has a two distinct real solution. We didn't know yet until we substitute with the values of A, B, and C. So A equals to minus 3, B equals to 27, and C equals to 66. By substituting with values of A, B, and C, we get B squared 27 minus 4A times C equals 729 minus 66 times 4 times negative 3 equals 261, and the answer is positive. So the answer is, the statement is correct. Thank you for sharing your time with us and watching this video. I hope it's useful for you. See you at the next video, and good luck to you all.